वेलकम बैक। तो आज न्यूटन्स लॉज के ऊपर बात करते हैं। पहले मैं क्लियर कट जो है न्यूटन का तीनों जो लॉ क्लियर कट जो न्यूटन सर ने अपने प्रिंसिपिया मैथमेटिका में पब्लिश किए थे, उसको उन लॉज को मैंने पहले डिफाइन कर देता हूँ। तो न्यूटन का फर्स्ट लॉ है, वो कहता है कि वो डेफिनेशन है एक चीज़ का, मैं बाद में बताऊँगा। न्यूटन का फर्स्ट लॉ कहता है कि एक पार्टिकल का एक्सेलरेशन ज़ीरो होगा जब उस पार्टिकल के ऊपर नेट फोर्स ज़ीरो है। पार्टिकल के ऊपर इंडिविजुअल फोर्सेस लग सकते हैं, पर नेट फोर्स अगर उस पार्टिकल का ऊपर ज़ीरो है तो उस पार्टिकल का जो एक्सेलरेशन होगा वो भी ज़ीरो होगा। Newton's first law sets the stage for proceeding to Newton's second law. What is Newton's second law? Newton's second law says that the acceleration of a particle is equal to the net force on the particle divided by the mass. Newton's second law is not the rate of change of momentum of a particle. This is the combination of Newton's second law and third law, which we'll learn in center of mass chapter, in linear momentum, all those concepts. But Newton's second law and first law is only for particles. Newton's second law is that acceleration of a particle is equal to the net force on the particle divided by the mass of the particle. And Newton's third law, the most means this law is most complicated type. We say it's very easy. It's not that every action has an equal and opposite reaction. Its clear-cut definition is let there be two particles, particle A and particle B. If particle A applies a force F on particle B, then particle B will apply a force minus F on particle A. Means this F force is a vector quantity, minus represents the direction. If this particle applies a force on this in this direction, this particle will apply a force on this in this direction. The magnitude of the forces will be same, but the direction will be opposite. Suppose if an object, like I keep this pen on my hand, the force, what are the forces on this body, not by this body, on this body? First, the normal force exerted by my hand on this pen. Second, the force of gravity exerted by the earth on this pen. But these are not Newton's third law action reaction pair. These are not the third law because they are acting on the same body, and the nature of the forces are different. Normal force is electromagnetic in nature, electromagnetic force, normal friction, tension, all these forces. But the force which earth is applying, it is gravitational force, non-contact gravitational force. So this is not the action reaction pair. The action reaction pair which can see is the pen is applying a force of gravity on the earth, and the earth is also applying a force of gravity on this pen. My hand is applying a force on this pen, normal force, and the pen is also applying a normal force on the hand. So these normal forces, they are also the action reaction pair. In a free body diagram of a body, we only show the forces acting on the body. Therefore, we cannot show the Newton's third law action reaction pair on a body. For a single body, we cannot show the Newton's third law action reaction pair. There has to be two bodies. First will apply on second, second will apply on first, magnitude same, direction opposite. Now let's talk about inertial and non-inertial frames of references. So what is inertial frame? What is inertial frame? Then we'll define non-inertial. We define inertial frame as those frames of references whose acceleration is zero with respect to another inertial frame. So in the definition of inertial frame, we require the help of inertial frame. So this is not the actual definition. The actual definition of inertial frame is the frame in which Newton's first law is valid. If no force is acting, the particle will remain unaccelerated, and if some net force is acting on the particle, it will accelerate. This is the Newton's first law. So Newton's first law makes a stage for applying the Newton's second law, because in non-inertial frames of references we cannot apply Newton's second law. Only in inertial frame of references we can apply Newton's second law. From this we can say that those people who derive Newton's first law from second. How? A is equals to F net by M. If F net equals to 0, equals to 0, thus prove Newton's first law. It is a law, we cannot prove it. It was given by Newton, sir. It was a law which he found by experimenting. And when we are applying Newton's law to find the first law, the first question is which frame you are using, non-inertial or inertial. If you say inertial, then how do you know that it is inertial without using the Newton's first law? And if you say non-inertial, how can you apply Newton's second law in non-inertial frames? If you are saying inertial, then how you find it? You must have used the Newton's first law, because the definition of inertial frame is those frames in which the Newton's first law A is equals to 0 if F net on the particle is 0 is valid only in inertial frames of references. Therefore, you cannot derive Newton's Newton's first law from Newton's second law of motion. These are the three independent laws. Newton's first law is the most fundamental. That will, I summarize once more, that Newton's first law will set up the stage, will give you the green signal, will give you the permission that yes, you can use Newton's second law, and then you apply the Newton's second law for analyzing the dynamics of the particles. Newton's third law, independent, it will is valid everywhere. I repeat once more, what is the third law? If a particle A is applying a force on particle B, particle B will apply a force minus F on particle A, and the forces act along the line joining the two particles. For example, if these two particles, this particle cannot apply a force on like this in this direction on this particle. We will apply like this on the line joining the two particles. So this is the Newton's third law. This was a more or less summarization of the laws. So that's it. Have a good day.